We're going to go ahead and take a look at differentials. Differentials are basically if you're using your tangent line, how much would your y value change? Now, that's one way to look at differentials. Another way to look at differentials is basically it's your derivative, which we would have here. So if you had y equals x squared, your derivative, you know, is dy over dx equaling 2x. Your differential is basically where you get your dy by itself. So to get rid of dy or get rid of the dx in the bottom, you just multiply both sides by dx. And so you would get this. This is your differential, where the dx is basically your change in your x, or how much your x value is changing. So here you have your derivatives in the middle column and your differentials in the far right. You notice all your differentials are basically the same as your derivative, just all multiplied by dx. So let's go ahead and find our differentials here. Well, we need to take our derivative. Put your exponent down in front, decrease it by half. So when you're looking for a differential, all you have to do is just multiply both sides by dx. And that's your differential in red. You want to do the same thing over here on this one. Keep in mind, though, that you end up having two things multiplied together, so you're going to have to use a product rule here. Derivative of the first times the second, plus the first times derivative of the second. Then to get your differential, you got to just go ahead and take what you had on the right, multiply it by a dx. Here we want to go ahead and use differentials to approximate this. Well, we're dealing with a square root, and so we're going to look at our square root function. And we want to say, okay, as we are looking at this right here, we're going to use that to approximate this. So we're going to start off with your original function plus your derivative times your dx, meaning this right here is just really your differential. Well, your function, once again, is the square root of x. Then you got to go your differential, so you got to take your derivative of this. Well, you should realize or remember that the derivative, it's x to the 1/2, put your 1/2 in front, decrease your exponent by 1. You end up getting this, still multiplied by your dx, which is essentially your change in your x. So, what number is close to 16.5 that you could easily take the square root of? Well, most of you will realize you could easily take the square root of 16. So that's what our x is going to be. So we'll go to the square root of 16 plus, then we'll go ahead and take our derivative right here, plug 16 in there. Then we're going to multiply it by dx, or delta x, which is how much our x is changing. We're plugging in 16, but we're looking at a 16.5, so there's a total difference of a half. So you're plugging in a half there. Well, square root of 16 is 4. Square root of 16 is 4 here, so it'd be 1 over 2 times a 4, 1/8. That's a half. So you really get a 16th here. So it's really 4 plus a 16th. Decimal-wise, it ends up being this. That's essentially what we're looking for. Now, there may be times where you're also asked to find a dy. If you're asked to find not a dy, I mean a delta y. If you're asked to find delta y, what you would want to do is you would want to go ahead and look at the change in your y values. Well, we had put 16 into our function and we got out 4. You'd also want to go ahead and put 16.5 into your function and then look at what you get out and then change this into the output by taking 16.5 and plugging it into your function. When you do that, as you see down here, in our decimal approximation, we get a 4.062. Well, your change in y is the difference in these two y values. So you take the big one minus the small one, so your dy is really just the 0.062. So if you're ever looking for dy, you plug in your two values and subtract the two y values because you're looking for your change.